Hello and welcome back. So far we have talked about, or you watch videos on, what is light. We can't see most light. Okay, it's a wave in a particle. Then you talked about what can happen to light. It can be reflected, it can be refracted, it can be absorbed. Now we're going to talk about the electromagnetic spectrum, which is basically looking at the full spectrum of light waves, okay, So this form you're either filling out now as you watch this, or you are filling it out at some point during class, but you will have this. So light is particles and waves. It's photons. Light is made of photons. We're not going to get into the duality of particles and waves, but there is a frequency, or there are light waves. Okay, and here's an example of a light wave. It is a wavelength. So we're going to be talking about wavelengths of light, most that you cannot see. Okay. So with one wavelength, you go from crest to crest. That is a wavelength. So when we look at the length of a wavelength, it is from crest to crest. Okay, from crest to crest. So the electromagnetic spectrum is a continuous range of frequencies for electromagnetic radiation. But again, think of that as light. Okay. Again, in our head, when we think of light, we think of things we can see. But most of the wavelengths of light are not visible to us because we don't have the receptors for them. What I always find interesting is we knew from a scientific standpoint that these waves existed before we could even prove that they were there. So scientifically or mathematically, scientists could show they were there. We knew they existed, but we didn't have the technology to actually detect them. So we knew they were there before we could detect them. As our technology improved, we were able to then detect them and then turn them into something we could visualize. So with your project for this, you are going to be looking at how different objects in space can be viewed, and I use the word viewed loosely, in these different wavelengths. So what telescopes do, the Hubble, the James Webb Space Telescope, is they can sense these waves with detectors, and then that information can be then converted into something that we can visualize. Okay, that we can visualize. Okay, so we're talking about the electromagnetic spectrum. We go from the longest wavelength from here to here, down to the shortest wavelength down here. Okay. The longest wavelengths are radio waves. The shortest wavelengths are gamma rays. Up here, it shows you gamma rays are the shortest, and then the wavelengths get longer as you go, in this example, down. Now here, there are exact sizes of these wavelengths. I don't care if you know that, okay? So you don't have to write all these numbers down. If you want to, you can. But gamma rays have the shortest wavelength. Radio waves have the longest wavelength. Okay. Radio waves are incredibly large. They're the size of buildings. Okay, they're the size of building. Gamma rays are very, 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 very tiny. Okay, so from short wavelengths to long wavelengths, short wavelengths to long wavelengths. Again, the wavelength being the distance from crest to crest here. Okay, also when you use this example, as you go from radio waves to gamma rays, the energy increases. Okay? There is more energy, a lot more energy in gamma rays than there is in radio waves. So low energy to high energy. Okay? This high energy can be beneficial, but it can also be bad for us. Okay? The other thing that happens is the frequency increases. So the frequency is the number of wavelengths in a second, okay? The number of wavelengths in a second. So you have low frequency here, okay, and you have high frequency here. So let's go through these examples again. Okay. We go from a long wavelength to radio waves down to a very small or short wavelength. Okay. You go from low energy to high energy, and we go from low frequency to high frequency. Okay. Okay, so let's talk about each of the wavelengths. We will do a kind of lab activity, assuming when we come back to school, that will let you represent all of these. Also may be part of your assignment. And then we will go through more examples of each of them. Okay, so radio waves. Radio waves are the longest waves at the lowest energy and the lowest frequency. They're used for radio communication. Okay, they're used for radio communication. So you've all used them. Okay, so they are the longest wavelengths, okay, of all the wavelengths. Now, we think of radio waves as being human produced, but the universe is also produced radio waves. So nebula, galaxies, the universe itself when it was created will put out radio waves that we can detect. Okay. The next wavelength going from longest to shortest, a little bit shorter, is microwaves. Okay, is microwaves. Now I will tell you, there's not an exact line here where one ends and starts, and there is, but humans have done that. Okay, humans have said from here to here is going to be microwaves. From here to here is going to be radio waves, but it's a continuous spectrum. So microwaves, we're all familiar with it. Microwaves are shorter than radio waves, have a little more energy. Okay, have a little more energy. They are used in microwave ovens, obviously, and for wireless communications like cell phones and Wi-Fi. So without microwaves, you cannot use your phone. Okay. Now, how microwaves work to heat things is the wavelength of microwaves is the perfect wavelength to excite a water molecule. Okay. So when that wave comes through a water molecule, it's the perfect frequency in order to add energy to that water molecule. So when you put food in a microwave oven and you inundate that food with microwaves, it heats up or it energizes water molecules, which heats up the food. Okay, which heats up the food. So you have to have water in food in order for it to heat it up. It energizes those water molecules to do that. Okay. All right, next, and again, we can't see radio waves, we can't see microwaves. Okay. Infrared are the next shortest. Again, a higher frequency, more energy than microwaves. They're used for thermal energy, including night vision. So I will show you a picture at some point where, again, sensors are going to sense infrared waves, and then technology converts it into an image we can see. But you can see heat with infrared. Okay, so night vision. Our night vision as humans is not very good. And so if you catch the infrared waves coming from the objects in the night, what will happen is the sensors will connect or catch them, and then technology will convert it into something you can see. Okay. And meteorology, the study of weather, also uses infrared. Okay. Okay, then we get down to a higher frequency, shorter wavelength with more energy, and that is visible light. This is what we can see. Okay. These are all examples of light, but this is what we can see. Now, why can we see it? We can see it because in our eyes, there are things called rods and cones in the back of your eye on the retina that actually respond to this frequency of light waves. Okay? So we have evolved to be able to sense this range of the electromagnetic spectrum. Okay? So you may have heard of Roy G. Biv. So these colors, which you need to make sure in your drawing when you do it, you have them accurately, spells out Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet. So we have receptors in our eyes that allow us to see these, to sense them. So the frequency hits those rods and cones in our eye, signals are sent to our brain, and we interpret the color that we've seen. Okay, we interpret the color that we've seen. Some animals have sensors for infrared. Others have sensors for ultraviolet. So there are other animals that can see these other waves that we cannot. Okay. So we will talk more about visible light in detail later. Also, to understand when we look at the Big Bang Theory and how our universe is forming and moving, how light changes as it's moving away from us or towards us deals with the visible light. Okay, and we'll get into that. Next is the ultraviolet. Again, now we're getting into the higher energy wavelengths. Okay, so the wavelength has gotten smaller, the energy has gone up. So ultraviolet, our sun puts out all of these wavelengths. Okay, all of these wavelengths. So it puts out visible light, which we can obviously see. It puts out ultraviolet. So the ultraviolet we can't see, but it has more energy, and what it can do is it can cause your cells of your skin to burn. So it's a higher energy, so it can lead to sunburns if you're exposed to too much. Okay, so that's kind of a negative of it. I will tell you, when you tanning is still bad for you. Sunburns are worse for you, even though they're both bad, because what it means is you're damaging the DNA in your skin cells, which can lead to cancer. So that is kind of a bad aspect of ultraviolet. A good aspect of ultraviolet, though, we can use it to disinfect. So I just bought my cats and bought me a litter box that is automatically cleaned. So I did that because I'm just sick of cleaning litter boxes. But it has a ultraviolet disinfection mode. So when a cat is not in it, I can press this button. It sends out ultraviolet light, and what that does is it kills any bacteria or fungus that may be in the litter box. Okay, so again, higher energy waves, we can use it to kill. We've talked about fungus. We grew bacteria. Again, most of them are good for us, but in a litter box, probably not. And so we can use it to disinfect. Okay, we can use it to disinfect. Okay, so now we're going down. We're going smaller waves with higher energy. And now we have X-rays, which you've all heard of. And some of you may have had X-rays done. So X-rays are used for medical imaging. They can pick up bones. The bones will actually absorb. Okay, will absorb the X-rays, and so we can visualize them. We can visualize them. So X-rays can be good. Now X-rays can be bad. If you're exposed to too much X-rays, that can actually cause cancer again, because these higher energy waves can damage your DNA, which can lead to cancer. So my dad always tells me, when he was a kid, and he's in his mid-80s now, when he was a kid, every time they got new shoes, they would X-ray their feet. So X-rays looked pretty cool at one point, because they were new and it was cool. But again, that could cause damage to your feet and your bones and can lead to problems. So obviously they don't do that anymore. So X-rays are good. You need to have them, but you always need to limit them. So you guys are at an age where your molars, your wisdom teeth are coming in, and they will be taking X-rays of your mouth probably almost every time you go to the dentist. And that's good because we need to see them. But when you start to get older, you probably want to decrease the number of X-rays you have. If you notice, when you have X-rays done, either the people in the room have a big lead vest on, which blocks X-rays, or they leave the room. Okay, so you kind of want to minimize that. Okay, so then we get down to X-rays, and then we get down to the smallest, highest energy wavelength, which is gamma rays. So gamma rays can cause cancer. Very high energy, okay? Very high energy. They are naturally occurring in the universe, just like X-rays, ultraviolet, but at high energy, they're high energy, they can cause issues. They can cause burns. They are used to sterilize, okay? They are also used, and this is kind of weird, but gamma rays can cause cancer, but they can also cure cancer. So when a person has cancer, which is a bunch of abnormal cells, let's say you have a tumor, they can beam it with gamma rays in order to kill it. Okay? Now it can cause burning, it can cause issues with the skin. So if a woman has a breast cancer that may be like a single tumor in her breast, they can beam it. They can beam it with gamma rays. Now it will kill it, but it will also cause burning on the skin above it and can cause some damage around it. Okay, so gamma rays can cause cancer, but they can actually be used to cure cancer. They can also be used to sterilize medical equipment. Again, because they're small enough, they're going to invade or kill bacteria, just kind of like the UV light does. Okay. Now, these are the rays. You need to be familiar with all these. We'll go over some more in detail. But understand what your project is going to be is that everything in the universe puts off all these rays. And each of these different types of rays or wavelengths can teach you different qualities or characteristics of exoplanets, which are planets outside our solar system, about nebula, about galaxies, about all these structures and understanding the universe around us. So, the Hubble Space Telescope, the James Webb Space Telescope, don't sense things in the visual, but they sense things in the infrared and looking at other rays or other wavelengths coming from these different structures. So by using and being able to sense the different waves coming from, let's say, a nebula, we can learn a lot about that nebula. So you're going to pick a structure, which we'll talk about, and you're going to look at how has it been viewed, which wavelengths has it been viewed in, and what did we learn about that structure from looking at the different wavelengths. Okay, so I know this is a longer video, but it covers everything on here. So you're going to fill out this form, and then, like I said, we'll go over some other things in more detail. So if you're listening to this now in 2025, we're still kind of in a snow thing, so we will see. So I hope you've gotten a chance to go out and play in the snow as well as keep up with your schoolwork. So I will see you all soon.